Hello all, welcome to the Cloud Computing lecture series. I'm Dr. P. Uma Maheshwari, Professor, College of Engineering, Guindy, Anna University, Chennai. This is the session 1 that includes what is cloud computing. Let's understand first basically the characteristics of clouds and the standard architecture, NIST reference architecture model, and the components of cloud, and finally challenges and features of cloud. Cloud computing today is a phenomenal term which is a modern computing paradigm which actually provides very scalable and flexible and very importantly cost effective computing services. Why it is cost effective? Because we don't need to establish any infrastructure. We need not to invest more on infrastructure establishment. That's why it's cost effective. So no infrastructure investment. And also you can access this facility. You can compute from anywhere from the world. So it's a global access. And because we can able to get more access onto the computing power as and when needed, the performance is high in this case. Suppose if you have our own physical infrastructure, whenever there is a change in the trend of in the power of CPU, or suppose we sometimes need graphical processing power, immediately we cannot set up that infrastructure. We need to again invest and it takes time. But the high computing power when it is needed, we have low infrastructure, then definitely the performance will be low. But cloud computing always the efficient and powerful services and resources can be accessed anytime. The performance we can expect at a high rate. Let's first understand basically what is cloud computing. Cloud computing is a on-demand delivery of computing services, all computing services, whatever it is, server, storage, database, network, software, and the more, over the internet. The services are made available to the user over the internet with the pay as you go price. Whatever you use, for that only you need to pay. Let's first discuss about the key characteristics of cloud computing. The first characteristic is given as on-demand self-service. What is on-demand self-service? Simply say, user can automatically get computing resources, whatever is offered over the cloud, like our server time, storage, databases, and applications, whenever we need it, without any human intervention, not or stop or increase, decrease resources by themselves, right, using a control panel API. Whenever we attach to a cloud provider, the API will be making us to operate the control panel available. Through this control panel, you can start, stop, and increase, delete resources without calling the provider again or mailing them or using any paper documents and all. Not necessary. Once you got the service, anytime you can automatically access it. That's what it is told. And the second key characteristic is broad network access. Broad network access means the cloud services and resources are available over the internet and can access from anywhere else. Just like that, we can access our own mail account from any part of the country at any time because it is available onto the internet. So you can access this service over your own device, any device like laptop or mobile phones, any device, desktop, tablet, anything. If you want to say simply, the service can be used anytime, anywhere, on any device, as long as the internet connection is established. For example, Microsoft Office 365 onto our mobile phone, onto our tablet, onto our desktop, such a stuff this particular point includes. Then the third key characteristic here is resource pooling. What is resource pooling? Resources are shared between multiple users. The resources are not restricted, it includes all servers, storage, memory, and even network bandwidth can be shared among multiple users. The users here are termed as tenants. Tenants. So multiple users are using the service at a time. So this is a multi-tenant model. The user do not know or control the exact physical location of the resource, but they can specify general location. For example, from in what region they wanted to store their data, either in India or outside India. So that freedom is available always to the user. But anyway, many customers share the same pool of resources, and cloud provider dynamically assign or reassign them based on the customer demand. Right? For example, the next key characteristic is the rapid elasticity. Rapid elasticity. Here, the cloud is provisioning the user scale up and down the necessary resources on demand basis very quickly. Right? So this means cloud resources can be quickly increased or decreased according to the user demand. According to the user demand, an e-commerce site automatically add more servers during festival times because many purchase will happen during the festival sale or weekend sale, mega sale, by the time they will try to get more servers, the other time they may reduce. So such a way we can understand. Then the final characteristic is pay as you go. The pay as you go is actually the very important feature where the user wants to pay only for the resources and services they actually use. They need not to pay for the one they don't use, right? For example, if you want to run a virtual machine for 2 hours, for the 2 hours only they need to pay. Suppose if they want 100 GB data, what they use, they will pay, not for the other storage, right? So that way of flexibility the cloud services are always giving us. So these are the key characteristics. Let's move on to the next topic called the cloud architecture. There is a front end part and a back end part. The front end is user side. Here are the users, right? So the tenants, we can in a more specific term, we can say they are tenants, right? The the tenants are termed as client are always have their own infrastructure, maybe the devices what they may use to connect the cloud, maybe their desktop. The backend here is the cloud side. This part, this part is a client side, cloud side, sorry, cloud side. So cloud side, there is there, service is there, run there, storage is there, infrastructure is there, management is there, and security part is there. So these as a whole made a backend part of the cloud where actually the place the cloud provider, that is who is creating all these things and offering the service to the n number of users. So let's see first the application layer of the provider's cloud side, which provides cloud-based applications. For example, Gmail, Google Doc, and Drive, and all are applications. That's what application layer includes. And service layer includes the different types of services offered by the cloud. Actually, there are three types of services: infrastructure as a service, platform as a service, and software as a service. All these three are always is provided by the service layer. Let's discuss these things in later classes. And runtime layer. This runtime layer is actually the code execution layer where the application code is being executed. The application written in any languages, Java, Python, and Node.js, any language, .NET, anything can be run on here. So that can be a necessary infrastructure this layer is having. And then the storage layer, which stores the data. It may take any of the form, object storage or file system storage, anything. Like every provider has its own storage layer facility. For example, if AWS is offering S3, Glacier as a storage layer, and this infrastructure layer actually includes all the physical hardwares like servers, so storage devices like hard disks, network equipments like switches and routers, and the data center establishments. And here the management console, this is actually the policies and ensuring how much service the particular user is utilized and what is the charge to be. So that and all will be taken care, and what are all the resources are availed by which user, how long they are going to use, like that, right? All managerial aspects, this management of the layer will take care of. And security is a very important aspect of any services. So here always we understand the cloud services are offered over the internet. Definitely it is vulnerable for attacks, different kinds of attacks. And the user actually believes on their own data is kept very securely onto the cloud storage. So that is ensured through all security mechanisms and protocols offered by the cloud provider. So these important components of the cloud infrastructure. The first component is the network component. Because the cloud is offered over the internet, we need to have network component. All networking technologies like TCP/IP, UDPs, IPv6, IPv4 protocols, subnets, nets, domain, and all networking technologies come into picture. The hardware is necessary because we used to have routers, switches, and all gateways. So definitely networking technology is the essential for cloud computing. And the hardwares, all the computer hardwares, CPUs, GPUs, servers, storage, everything. And the virtualization, this is the new term, what is new, that is in computing environment, virtualization is the very crucial and important component of cloud computing. What is virtualization? Virtualization is actually the technology. It is actually a software technology. There is no hardware involved. Software which makes the physical hardware located in one physical location but made available to the user who all around the world to is called virtualization technology. Obviously the storage takes part as a component of cloud structure. So let's briefly discuss everything in the future sessions. And now come on to the NIST reference architecture. NIST is the organization based on USA which actually proposed the reference architecture. To note down, there are role players in cloud computing. So who is the cloud consumer? He is the role player, and cloud provider, another role player, and the intermittent persons, cloud brokers, and the one who need always, there are certain standards. Once the standard is exposed, everyone has to follow. So somebody, third party, has to ensure that the standards are followed. No, that is what the cloud auditor. And the fifth role player is cloud carrier. We all of us may confused what is a carrier. So this is the carrier whenever you use a smart TV or TV. Yeah, so simply I say you are using a broadband, right? Who is the carrier for it? Maybe Airtel or BSNL or Geo, like no. So such a carrier. So because the cloud services are availed through internet, Definitely, the internet carrier offers will come into picture, like BSNL, Geo Fiber, there is Geo, Airtel. These persons are said to be cloud carrier. So let's first see who are cloud consumers. The cloud consumers are the users who wanted to take the service from the cloud provider. So cloud providers are obviously the one who actually set up the all the infrastructures and services and offer those services to the users. So they have their own cloud backend component. All the cloud backend component are here. That is to be ensured, developed and maintained by the provider. And the cloud broker is the one who actually have a good contract with the cloud provider and as well the orchestrate the services. And the auditor is the one who actually ensure the security is provided, pretended, and privacy is ensured and the performance is good, right? So let's move on to the cloud-defined NSTE, NAST cloud model. As usual, this the deployment. Actually, the cloud, whatever type of cloud it is, whatever cloud provider, they may offer the service in four different deployment models, either a public cloud or a private cloud or hybrid of both and community cloud. So we will briefly discuss these cloud model in the forthcoming classes. So the public cloud services can be offered in three different service models: software as a service, platform as a service, and infrastructure as a service. Software, suppose we are offering only the software as a service, for example, Microsoft 360, 365. This is a software. This is offered as a service or as a cloud service. And then platforms, suppose the necessary computing platform, like CPU platform, necessary computing platform with enough operating system environment, Power BI, like Power BI for analytical framework, right? So that platform as a service also can be offered, and the infrastructure as a service, the necessary infrastructure like hardware, servers, data center, for example, data center. Recently, you would have heard about the new data center that Google is establishing at Andhra Pradesh. A very big data center. Imagine a data center will be of size pretty much bigger than a mall, shopping mall. So that is the infrastructure as a service. Data center is the example. And on-demand self-service, broadband, broad nexus, these things we'd have heard about. No, these are the key characteristics of cloud. So this is going to be the essential for any cloud operation. This is essential. That's what NIST is insisting. Let's move on to the role players of the cloud. As I already mentioned, there is a cloud consumer, cloud auditor, cloud provider. Always there is a consumer for who consumes the cloud services provided by the provider. And always the mediator, intermediators between consumer and the provider is the one who is the broker. And the cloud auditor is monitoring whether the consumer and the cloud provider is agreed upon whatever they agreed upon, whatever it is promised to provide, is it within the standard and norms. So the consumer is the person or sometimes an organization which uses cloud service. They used to have service level agreement with the provider. Service level agreement, what is service level agreement? So that we will discuss further. And he monitors the usage and makes payment for the service he used. And the cloud auditor is an independent body who checks the security performance compliances governance with the cloud and ensures the cloud services are followed as per the required standard. The broker is the one who acts as an intermediate between consumer and multiple providers. He do intermediation, mediation, service aggregation, and arbitrage. For example, a cloud consumer needs storage from AWS, but computing from Google App Engine. So the broker will have both the access, both the vessel is a service, and he offers as per the client need, right? So that's what actually the broker's role. And provider is the major role player here, who is the organization that offers and manage cloud service. They create their own cloud infrastructure, and they create their management and security concerns, and they make ensure their duty to ensure the security and availability of the cloud all around the cloud, 24 bar 7. PaaS and SaaS, any of the models, deployment model, public or private or hybrid or community, right? This is actually about the cloud computing. The cloud carrier, as I said, is a network provider who provide connectivity between consumer and providers. So the cloud provider actually have three layers of service, as I said: physical resource layer. Physical resource consists of physical computing, storages, networking resources. What are all the resources? Maybe the server, GPUs, CPUs, TPUs, processors, and all storage resources like hard disk drives, solid state drives, SAN, the storage area network attached storages, network resources like routers, firewalls, physical cable and load balancer, data center infrastructures like cooling system, power supply, UPS, backup generation, fire suppression system, physical security, and all. Resource abstraction and control layer is takes about which hide the complexity of the physical hardware and its connectivity. Present it as a virtual, manageable, scalable resource like a virtual machine or a storage or a container basis, anything to the user. So the responsibility of this layer is to convert the physical version into virtual version, allocate and monitor the resources that have been allocated used by the user, ensure isolation between users. For example, user 1 has used 2 VMs, user 2 used 2 VMs. The the two VMs used by the user 1 is not available for the second user. It is isolated completely. And optimizing the performance by scaling and up and down, handle automation and scaling, and security and security provision at all levels. Here the technologies used are virtualization, where the physical machine is split into different number of virtual machines, and containerization may be another technology which is an alternative, lightweight alternative to virtual machine. For example, Docker, Kubernetes, and all. Resource management and scheduling includes VM creation, deletion, allocation, load balancing, auto scaling, and the kind. A software-defined infrastructure makes the entire infrastructure programmable and flexible, automatically configured as per these necessary specifications. Which is software-defined networking like SDN, a software-defined storage called SDS. Finally, the service layer includes NAST computing service architecture, representing the set of services that are delivered to a consumer. And it defines what is the type of service it is, whether it is infrastructure as a service, platform, or software as a service. So this is how actually the service layer is orchestrated. And every layer, IaaS infrastructure as a service, definitely having APIs, which is application programming interface, and necessary connectivity, hardware, facilities, and OS kind of stuff. And suppose if it is a cloud platform as a service, then definitely there should be an integration middleware and API. And for software as a service, there should be definitely a presentation layer, API connected, application what is being serviced, and the necessary data and content, right? So this is what NIST reference architecture says. And finally, but not least, we have to understand the challenges behind the cloud computing. One is the cost management. How much costing for required for a provider to provide necessary services, and governance and control issues at par with the region where the cloud is hosted. Suppose if it is in India, it is to be according to the Indian policy, data privacy policy. If it is in US, then they have to comply with the US government policies. And managing multiple clouds. is another challenge. And building a private cloud is a big challenge and provide and ensure security to the cloud. And lack of resources and expertise nowadays, they're very much essential to have a skilled expertise for managing the cloud architecture. The cloud architects have high demand nowadays, and compliances, and finally the performance. And see the future of cloud. We are now at 2025. In towards 2030, what are all the updations the cloud computing may expect to emerge? Rapid use of multi-cloud, more than one cloud use at the same time, artificial intelligence integrated with cloud, better security measures, blockchain technology integration with cloud, edge computing, fusion on cloud native development, and finally usage of cloud orchestration, rapid usage of cloud orchestration. So these are all actually the futuristic expectations that the cloud almost already AIs are integrated slowly, and also edge computing is emerged, right? But the full-fledged implementation is expected to be completed by 2030. Yeah, we and come to the end of the session, and finally we have something what is plus and minus of the cloud. The plus are scale and cost, change management, next generation architecture, and choice of agility are plus points, but lack of control, reliability, lock-in period, and the provider and security are minus negative aspects of